Hello everyone. Today I'm going to show you the quickest way to test whether a 3 or 4 digit number is prime. Now you can do this with larger digit numbers, but it will take a long time. This is optimal for 1, 2, 3, or 4 digit numbers. So let's just get into it. What you do is take your number, take the square root, and then take the floor of that number. So that's the first step. Now let's just work with an example. Let's work with 287, this number. I want to test whether or not this number is prime. So the first thing I do is take the square root. Now I do not know the exact square root of the number, but I do know that the square root is about 16.9 something. I know that. Now, I took the square root, so now I have to find the floor of 16.9 something. So remember, the floor of a function is to basically take a number and cut off the decimal part. So in this case, instead of 16.9 something, it just becomes 16. So we get 16. Now, what we do is a little bit difficult at first, but let me just tell you what to do. So you take this number, and then you test all the prime numbers less than or equal to this number, and you see whether these numbers divide your original number. So let me just try that now. So we have 16 over here. That means we're going to test if 2, 3, 5, 7, 11, or 13 divides 287. So let's just start with 2. Is 287 divided by 2 an integer? No, it is not. So we can skip to the next one. 3. Is 287 divisible by 3? Well, we can check. 2 plus 8 plus 7 is 17, and 17 is not divisible by 3. Therefore, 287 is not divisible by 3. What about 5? Well, no. Every number that's divisible by 5 either ends in 5 or 0, and in this case, it does not. Now, what about 7? Well, I don't really have any tricks for 7, so let's just do it the old-fashioned way. 287 divided by 7. Let's see, 7 goes into 0 times. 7 goes into 28 4 times, so 7 times 4 equals 28. 28 minus 28 is 0. We bring down the 7. 7 times 1 is 7, and we get 0, so 41. So, 7 divides 287 cleanly. That means that 287 is not a prime number because 7 divides 287. Therefore, we can conclude 287 is not prime. Let's try this one more time with a little bit easier example. Let's try 97. So taking the square root of that, let's see, 10 times 10 is 100, so it's less than 10. So it's going to be about 9 point something. Now, taking the floor, we can ignore that decimal part, and we get 9. So now we just have to check all the divisors up to 9 that are prime and see if it divides 97. Does 2 divide 97? No, it is not. 97 is odd. Does 3 divide 97? No. If we add the first and second digit together, we get 16. 16 is not divisible by 3, therefore 97 is not divisible by 3. What about 5? Nope. 5 will only work if it was 95 or 100, something that ends in a 5 or 0, but in this case ends in a 7. What about 7? This is the last one we have to check because it's below 9. We don't have to check 11 because 11 is greater than 9. So let's just see. Let's just do it the old-fashioned way, because once again, I do not have a good way of checking really quickly if it's divisible by 7. So you have 2, 7. 7 times, 3 equals 21, 6, so it's 13, remainder 6. It is not divisible by 7. Therefore, 97 is prime. So I hope this really helps you whenever you want to find a 1 to 4 digit number and check whether it is prime. This does work for larger digit numbers, again, but it's better to use this for 3 or 4 digit numbers, because once you get to 5 digit numbers, you're going to have to be checking a lot of divisors, and that will not be pretty. Anyway, see you next time.